Good morning, dear students. In our previous lecture, we discussed about various equipments which are used for separation of particulate matter from polluted air. Today, in this lecture, we'll talk about how to control the gaseous air pollutants. So, let's start our today's lecture. First of all, in very brief, we'll discuss again that how the gaseous pollutants can cause various types of problems in the environment. We know that the primary gaseous air pollutants are sulfur dioxide, carbon dioxide, oxides of nitrogen, as well as carbon monoxide. Now, if we talk about the oxides of sulfur, carbon, and oxides of nitrogen, together all these three pollutants, if combined with the water vapors in the atmosphere, this can result into formation of acid rain. And we know that acid rains have a capability to damage the crops. The acid exposed area also experiences loss of biodiversity. It also causes health issues to the humans and the animals. And finally, acid rain can cause damage to the buildings and property. This we have discussed in our previous lecture in detail. So apart from this, the carbon monoxide is also considered as one of the primary air pollutants, which, if inhaled by human beings and other living organisms, can result into lack of oxygen in the body, and which causes a state in which the oxygen concentration in the body depletes very fastly, leading to a state that is known as carboxyhemoglobinemia. In this case, the carbon monoxide combines with the hemoglobin in the blood, and it causes tiredness, letharginess to the person who is exposed to this high concentration of carbon monoxide. Now, talking about the role of these primary air pollutants in formation of secondary air pollutants. We also discussed in the previous lecture that if two or more than two primary air pollutants combine in the atmosphere, they can form a new air pollutant which is termed as secondary air pollutant. So, if nitrogen oxide combines with ozone in the atmosphere, it gives rise to formation of nitrogen dioxide, and this nitrogen dioxide, if combines with the volatile organic compounds, another form of primary air pollutant, in presence of sunlight acts as a catalyst in this reaction. It led to formation of ozone. So ozone, if formed in troposphere, can cause various health issues to the living organisms, as well as it can cause different types of environmental issues. On the other hand, if nitrogen oxide combines with carbon monoxide in presence of sunlight, then also a secondary air pollutant ozone is formed in the troposphere. So these are several reactions through which the primary and secondary air pollutants are formed in the environment, and they start causing disturbances to the various sectors of environment on this earth. Now, talking about the control of these air pollutants, especially the control of gaseous air pollutants. So all these gaseous air pollutants can be controlled by three different methods. These are absorption method, adsorption method, and combustion method. So we'll discuss one by one about these methods and their advantages. So first of all, we'll start with the absorption method. In absorption method, the polluted air, which has air pollutants, is passed through a liquid which is known as an absorbent, and when this polluted air is passed through this liquid solution, the specific pollutant gets absorbed by this liquid absorbent and clean air can come out of this chamber. So this is the method of absorption. So for removal of specific air pollutant, the specific absorbent has to be used. Now, the efficiency of this absorption technique depends on various factors, such as amount of surface contact of gases with the adsorbent, the contact time, for how long these gases and absorbents are mixed, then the concentration of absorbing chemical. If the concentration of chemical is more, then absorption of particular air pollutant will be higher. And finally, the reaction speed between the absorbing chemical and the gas. All these factors will decide the efficiency of this absorption technique or method. Now, if we talk about the various equipments which are currently in practice for removal of these air pollutants by the absorption technology, these equipments are as follows. We have Venturi scrubbers, gas scrubbers as well as cyclone scrubbers. All these equipments are based on the principle of absorption technology for removal of pollutants from the gases. In this table, we can see that which specific absorbent is used for removal of any particular gas. For example, if we want to remove sulfur dioxide from the gas mixture, then the absorbent that should be used in this case are ammonium sulfate, sodium sulfite, calcium sulfite or calcium sulfate. If we want to remove hydrogen sulfide from the mixture of gases, then sodium hydroxide and phenol mixture is used as an absorbent. For removal of various oxides of nitrogen, which are commonly termed as NOx, water or aqueous nitric acid is used as an absorbent. So our selection will be based on what specific polluted gas we want to remove from the mixture of the gases. So that was all about the control of air pollutants through absorption technology. Now we'll discuss about the control of air pollution or the removal of air pollutants, especially the gases by adsorption method. In this method, the polluted gas is passed over a solid material which is termed as an adsorber, and that specific gas gets attached to the surface of that solid material, and in other words it gets adsorbed on the surface of that solid material and the clean air can be taken out. The efficiency of this adsorption technology depends on two things. First is physical and chemical characteristics of the adsorbent. The adsorbent which we are taking for removal of the polluted gases, what is the physical property of it? What is the total surface area of this adsorbent? How much is the humidity? What is the grain size? And what is the chemical composition of that adsorbent? All these things will decide that how much specific gas can be adsorbed on this specific solid material or adsorbent. The second factor that will influence the efficiency of adsorption technology is the concentration and the nature of gases as well as the adsorbent. The amount of gases present in the gas mixture as well as the nature of gases as well as the nature of adsorbent or the amount of adsorbent will also decide that what would be the outcome efficiency of this technology. Now the commonly used adsorbing materials are as follows. Uh, the most commonly used adsorbing material is activated carbon that is used for removal of organic solvent vapors from the polluted air. Then we have silica gel which is used for removal of oxides of nitrogen. When I talk about oxides of nitrogen, it includes nitrogen oxide, nitrogen dioxide, nitrous oxide, dinitrogen pentoxide, dinitrogen trioxide, etc. So, five different oxides of nitrogen are commonly removed using silica gel as an adsorbent. Next adsorbing material is activated alumina, which is used for removal of carbon dioxide from mixture of gases. Another material is zeolite, which is used for removal of hydrogen fluoride. So, for removal of specific gas, the specific adsorbing material has to be selected. So, that was all about the removal of polluted gases using the adsorption technology. Now, we'll talk about the combustion technology. Combustion is also known as incineration, and this method involves oxidation of organic air pollutants by combining it with the oxygen in presence of heat. If the mixture of gases has organic air pollutants such as volatile organic compounds, and if you want to remove these organic air pollutants from the mixture of gases, in that case combustion technology is preferred. And in this technology, the gas containing these organic pollutants are passed through a burner or the flame, and oxygen is supplied, and in presence of oxygen the volatile organic compounds or all the organic air pollutants are converted into carbon dioxide and water vapors. The equipments or the methods which are used for these combustion processes are: first, a direct combustor. In this equipment, the organic pollutants, for example, volatile organic compounds, react at the burner and get converted into carbon dioxide. The air is passed through a burning flame, and when air comes in contact with this burning flame, the volatile organic compounds or the organic pollutants get converted into carbon dioxide. The method is very simple, and in this method there is no residence chamber for the gas, or in other words we can say that gas is not allowed to be in contact with the burning flame for a very longer period. So that is the direct combustor or direct combustion method. Second equipment or the method that is used in combustion process is thermal incineration. In this equipment, the raw gas or the polluted gas passes over a burner flame in a residence chamber. The burning of the gas will take place in a closed chamber that is known as combustion chamber. You can see it in this diagram also, that the gas is raw gas is entered with the help of fan and in a chamber, and a burner is placed in that particular chamber. Air is supplied and the gas is allowed to be in contact with this burner for some time, and in this process all the organic pollutants are converted into carbon dioxide. The efficiency of thermal incinerators are greater than 99%. Using these equipments we can convert most of the organic pollutants into carbon dioxide. So that was all about thermal incinerators. The third method or the equipment that is used in combustion process is known as catalytic incinerators. Actually, the catalytic incinerators are very much similar to the thermal incinerators. Uh, as we saw in the thermal incinerators, that the contact of burning flame and the gas was done in a closed chamber, which is known as residence chamber. And in catalytic incinerators also, the air is burnt in a closed chamber with the supply of oxygen. The main difference between a thermal incinerator and a catalytic incinerator is that in catalytic incinerators, after passing through the burning chamber, the gas passes through a catalytic bed. As this can be seen through this diagram, that in the burning chamber, the gas, after being burnt by the heat which is produced by the burner, is passed through a bed of catalyst. The catalyst promotes the oxidation of organic pollutants present in the gas at low temperatures. So, if we use the catalyst, then we do not need to burn or heat the gas to a very high temperature, because the catalytic bed or catalytic material can carry out oxidation of these organic pollutants at low temperature also. So the major benefit of catalytic incinerators is that this process helps in reducing the fuel consumption and the cost of fuel also. So because the oxidation can be carried out at low temperature compared to what was required in thermal incinerators. So the amount of fuel that will be used in this process is less compared to the previous equipment. So this can be seen through this diagram also. The raw gas is allowed to enter in a burning chamber which has a burning flame, and once it is heated up, then it is passed through the catalytic bed, which results into oxidation of organic pollutants into carbon dioxide and water vapors, and the clean air is passed through the heat exchanger to the outside. So this is how the gaseous pollutants are removed from a polluted gas mixture. So using absorption, adsorption, and combustion techniques. So that was all for today's lecture. In the next lecture, we'll talk about some more topics related to our units. So that was all about today. Thank you.